Welcome everyone for the introduction of bridge engineering. This course is offered to the senior level, which is under CE 08486, and also a graduate course number 08586. And basically, what we will cover in this semester is the fundamental principles of bridge engineering from different aspects. And today's lecture is, or the session of the lecture is dealing with topic number 1, which is Introduction to Bridge Engineering. My name is Islam Mantawi. I am an assistant professor in civil and environmental engineering at Rowan University in Henry Rowan College of Engineering. My background is structural and bridge engineering, and we do research in advanced technologies in bridge engineering. I will have this class co-sponsored with what's called industry partner, who will be part of the class as I'm going to be moving forward. So in this class, we will have several topics to cover throughout the semester. The first topic, which is going to be today's topic, is pretty much the introduction to bridge engineering, which I expect that I'm going to finish it in 1.5 sessions, which is a little bit less than a lecture. So session refers to 6:30 to 7:45 in one session. Other session will be from 8 p.m. to 9:15 p.m. and the two sessions make a lecture. So topic number 2 will be bridge system and geometry, which pretty much was topic number 1. Both of them will take us more like three sessions. And topic number 3 will focus on bridge loading. Topic number 4 focus on bridge analysis. And topic 5 will cover principles of designing concrete bridges from different aspects, from bridge decks to pre-stressed concrete girders to barriers, etc. Steel bridges will deal with design of steel bridges, mainly composite steel eye girders or built-up sections, and also will deal with design of bracing, horizontal bracing and cross bracing in a steel girder. And topic number 7 will be the bridge substructure. As you can see, the main heart of this course is topic 3, 4, 5, 6, which is bridge loading, bridge analysis, concrete bridges, and steel bridges. So just to acknowledge that part of those slides actually was adapted or adopted from some lecture from Dr. Ahmed Itani from University of Nevada, Reno, which we highly acknowledge. So pretty much the purpose of this session is to introduce you to bridge engineering, and assuming that most of the student didn't have a strong background in the difference between bridges and building. I know most of the students are good in structural analysis with some background in how to do structural analysis, design some steel structures. Some of you actually talk with me concrete course, design of reinforced concrete. So this course is structured to cover fundamentals of bridge engineering from analysis to design to construction for student that doesn't have any background in the area. So they're going to be selected topics throughout the semester, and this slide I'm trying to explain to you in a really simple way what is the difference between bridges and other structures, and some systems through that too. So what is bridges? If you want to think about what is bridges, bridges actually is a structure that cross two peaks to pass a valley. So if you have a highland area and it's crossed by a valley, in order to make a continuous passage of transport mode, you need to have a bridge in order to cover that or to continue that connect the two peaks. For example, if you have waterway, a river that cross two sides of a land, and you want to move from land A to land B, you want to create a bridge to pretty much cross that valley, which is in this case will be the waterway. The valley can be from the topology itself. As you drive over so many of our infrastructure and roads, you always see different valleys that cross the bridges. So I would say from a natural, as you can see here, you have two lands or two topology and a gap or a valley, and you can see here a group of ants form the bridge by their body in order to help the entire colony to pass from point 1 to point P, which is pretty much inspired by natural. So there is so many application or so many incidents in real life where you can see bridges from natural, and this is just one fun example. So let's say what kind of bridges that we have. We typically have type of the bridges, as you can see on the left hand side. You can see. Let me put the pointer so you can. So in the left side, you can see the pedestrian bridge, which a structure that, as I mentioned, cross some obstacles or topology or roadway, for example, in this example, to protect the pedestrian. You create a specific structure that allow uh, uh, walking mode of transport to move from one side of the road to another side of the road. Also, there is a type of bridges called utility bridge, which is pretty much bridges that are built to pass, electrical cable, internet cables, some other utilities. You also have a railway bridges, which is basically meant to carry transit or railway um, mode of transport. You have military bridges, which is basically during wars, they try to quickly move from one side to another, and this can be deployable bridges where you can put it and remove it as the scene of the war goes and can carry equipment. We also have the most famous mode of transport, which is highway bridges, which is basically that we use every day, which, as you can see here, left side and right side, here is the intersection with of different ramps of a bridge. Uh, Moving from bridge type to bridge classification, the first classification here I'm trying to emphasize on is related to geometry. So pretty much in this case, we will have geometry change from straight bridges, which mean that the bridge is in one line, which is kind of straight line. You can make a straight line from beginning to end of the bridge. Or you have also type of bridges. We have curved bridge, which is usually you can see it in our highway system clearly in large cities. Also, we do have what is so-called a skew bridge. It would mean that the bridge superstructure, which is the bridge deck and slab, is skewed in an angle to the substructure. And you can see it here actually is after one earthquake that some of those skewed superstructure or deck that failed, and you can clearly see that this type of bridge was skewed. Someone may confused with in the top view to see if it's straight and skew, but it's also clear from the downside of the bridge that it's either skew or straight bridge. We can also classify bridges by position. So for example, you can have double deck bridges, which mainly you do have two surface to drive. So one surface in the bottom surface, for example, will take you from north to south, and the other one will take you, which is a second level. It's like a building design, when you have two levels, take you from the opposite direction. You also have movable bridge, which basically in a water canal, it's very important to allow the bridge to open for ships and um, any um, any ship that actually passed the height of the structure. Similarly, draw bridges in this area. For example, in downtown Miami and Brickell area, you can see that those kind of bridges opens up to allow um, you know the tourism to go through those water canal or rivers. And here's example is Miami River and the ships and cruises. Also, there is lift span bridge, as you can see from this slide, that the entire span is lifted up to allow the ship to go through the waterway because you have restriction in height. Otherwise, as you can see here, if we build a bridge in this level, there is no way we'll have any shipments or ship to go through this waterway. We also have a swing type bridge, which with the superstructure swing around the pier, allowing a higher clearance to pass through the canal from the ships. We also classify bridges by span. So if you have a span less than 20 feet, this is not likely to be a bridge. We call it culvert, as you can see it here. It can be made of concrete or it can be made of just a typical steel, corrugated steel or aluminum structure. And if the span is actually between 50 and 200, I don't know, I think I covered that by my video, is also called short span if it's less than 50 feet. As you can see here, example of a short span bridge. There's always mid-span bridge when you have a span between 50 feet and 500 feet. And you have long span bridges, and this is actually the Delaware Memorial Bridge, as you can see, is a famous bridge structure for suspense structure, which is the span is more than 500 feet. There is some notable bridges actually that you can see here. I selected just 5 to show you that really bridges can be really nice and can provide aesthetics through different structures. So for example, here, this is Brooklyn Bridge, which was opened 1883, and it was the longest suspension bridge by that time. And it actually has span up to one of the span is up to 200 feet, and it's reaching a height of 276.5 feet above the water level. The other one is very famous, which is actually kind of tourists goes there to visit it so much and take some memories with them, is the Golden Gate Bridge in San Francisco, California. The Golden Gate Bridge is probably one of the most iconic bridges in the world. And it actually has those towers, two towers, that carry the bridge in a suspension system, and each tower at almost 746 feet tall. The following bridge is Sunshine Skyway Bridge in Tampa, Florida. And this is actually a cable stayed bridge, not suspension. And you can see really the cable stayed is just this 45-degree angles for cables that carry part of the superstructure, and there is part of the superstructure is hole between the cables, while the suspension is continuously suspended with the cable. There is some statistics here. The cable stay bridge cover length of 4.1 miles, which is very significant. and it's in both US 19 and Interstate 275 run across it. There is also a New River Road Bridge in West Virginia, and it was completed in 1977, and it was designed to solve some commuting problem and travel problems, where travel has to spend 40 minutes to detour around the river, which is solved by this bridge. And one of my favorite bridges, 7 Mile Bridge in Florida Keys, Florida, is actually a very nice bridge that connected Florida Keys to the Florida mainland. And it actually has 7 mile bridges that goes toward the Keys. I have provided some links to go through if you want to know more about those notable bridges. But moving from this topic to another topic related to what kind of bridge construction and what's so-called accelerated bridge construction. It is actually a new field that emerged 20 years ago or more on how to very much accelerate the construction of bridges by using different techniques. The first technique utilized prefabrication of bridge element and system, what's called PBES. Let me see if I can play the video here. And this is one of the examples of using prefabrication to mainly prefabricate all the bridge elements from beams to slabs to bridge deck to substructure off-site and connect them on-site. Here's, for example, replacement of one of the deteriorated bridges that happened overnight and over weekend. And you can see here the demolishment process. This is a time lapse of the removal of the bridge. So usually what they do is they detour the traffic overnight and weekend to different routes, and they have full access of the bridge location to remove the bridge, as you can see, as fast as during the night, clean up of the site after the removal. And here what you can see, they avoid having a huge activity for cast in place. And what they do now, after the cleanup is complete, is to bring to the side the prefabricated elements that can be placed and connected quickly together. You can see here the abutment walls are placed, and also you can see all the equipment moved in place, try to be ready to have the cranes set up. You can have part of the prefabricated elements start to be lifted overnight. This is a second night. And now we can see everything is ready to have the truck to come and unload the element, the bridge element that you can see here. Here is the exterior side of the bridge. And by time you move, the crane moves and place the girder one by one. And they are connected. And as you can see, the daytime, they're still working on it. And this is the final side module, and you will have a lot of backfill behind the abutments. As you can see, work in progress for the second night to seal the bridge, and just having the bridge in few days rather than cast in place technologies. You have now accelerated bridge construction. Now you can see they have the approach slabs, which is, as you can see on the left side, they can quickly connect the approach slabs. and full crew is working over the bridge to get it complete and done in less than a week. That involve closure of the, the traffic in this direction, detour it to another direction, and also traffic under the bridge and detour it under some other direction. In cast in place construction, it will always have a cycles of waiting time for the concrete to be cured. So this is actually eliminated by prefabrication and curing offsite before the actual construction. Looks like it was a rainy day, so they have to cover sheet to cover the bridge, and the bridge is ready to go. So very neat approach. In the second weekend, they do have the, the construction moving on. Still the second week, they do have casting the bridge deck very quickly, and you have the sheet to cure it after to cure the concrete. Here is overlays, bridge overlays, and you have the sheet to cover after you apply the overlays. While under the bridge, as you can see, the traffic is moving without an issue, while the traffic is detoured in the direction of the bridge. Very neat operation. This is kind of small scale because it's just one span bridge, but it's all actually scalable to other multi-span bridges too. They're very nice and neat time lapse that show the construction in just 2 weeks, and even they do have also the repaving of the road underneath it. Can see now getting advantage of the closure during the weekend to also pave the road underneath it. So moving to another technique for accelerated construction, the other technique called slide in place. So it's not it's different than prefabrication. So in slide in place, what we usually do is we build the entire of the structure and see here, we already built the bridge, and after that, we demolished the first one and applied the new bridge place to take advantage of, you know, time, viewing, of enter, and after that, demolish the existing one by the power that force and driving capability and good monitoring to make the fit up bridges to have no tolerance between the that may lead to huge construction problem later on. The most iconic place is actually the what's called SPMTs, which is self-propelled modular transport, which is basically completely building the bridge offside and moving in place, as you can see. And this is actually conclude the topic number one for us. And there is a lot of course keeping that we will be discussing in class. And for the purpose of this topic, please check your Canvas account for the course. I have uploaded most of the specification from AASHTO ninth edition, which we're gonna be using throughout the class. I also uploaded few documents from FSWA for design of steel bridges that we're gonna go through throughout the semester. Make sure that you go and read the syllabus, and it's also posted in Canvas, and also the Word file of the syllabus is attached. We do, as I mentioned, have industry partner will join us, 5 to 6 professional bridge engineers that will basically give us perspective of each topic in industry and how they utilize it. We will also be having a semester-long project, which basically I will be teaming up one grad student with at least 2 or 3 undergrad students to create groups to design different bridges in different states with different structure system from concrete to steel. We will be exposed to use of software to do those design and check by hand so to get both sides of the experience. We will have some time to communicate with the industry partner to get feedback. Details about industry partner is also included in the syllabus. I will be notifying you when they will join us, most likely remotely. One of them has interest to show in person. So this will be worked out throughout this class. So the goal is after one topic or two, we will have industry partners to present to the class how they interpret this information in a design firm, in a design office. We also gonna have quizzes. Attendance is very important. Also, we'll have a midterm exam and final exam. And everything is mentioned in the syllabus, so please make sure that you go through the syllabus and check it. My office hour is listed there is very much 1 hour before the class from 5 to 6 p.m. on Mondays, or by open door policy. If my door is open, you are welcome to come and ask any questions. I know the class is around 40 students, so it's high volume class. So please let me know if you have some circumstances that you are not able to attend. Otherwise, they're going to be dropping some grading because of the absence. I'll be more than happy to discuss any details about this class during the class session or during the office hours. Looking forward to meeting with you for the second topic, which very much will cover bridge systems and geometry.